Okay, today's lesson, 6-8. We're going to discuss a new set of numbers, a set of numbers called the imaginary numbers. So, um, actually our imaginary numbers objectives will be to be able to use these imaginary numbers and solve quadratic equations. And then we want to perform operations with complex numbers as well. So let's go and let's discover what an imaginary number really is. Now, if you take a look, and let's do this first. If you take a look and think about imaginary numbers, we've been dealing with real numbers, radicals, so rational and irrational, but imaginary numbers, start thinking, and I have some with numbers, some with not. If we start over here on the left and say, I'm thinking of an equation, x squared equals k. And when we solve that, if k was a positive number, we'd have plus or minus the square root of k. If k happened to be a negative number, then we would have had x equals plus or minus that negative square root. Now, let's do an example with numbers in each situation. So let's say k was 64. If we solve that, most of you would tell me x equals plus or minus 8. So I could get two solutions there for that equation. Right? But if k was negative 64, we'd be looking at x equals plus or minus the square root of negative 64. Again, it looks like two solutions, but over here we could say we had two solutions that were real numbers. Over here, they're not. They're irrational. Now, story goes that long ago, during research when transcripts were going back and forth across the oceans for people to prove and disprove other people's ideas, somebody said, well, this x squared equals negative 64 is a lot like the positive version, but it's got that negative in the way. So it says that somebody got the great idea to say, well, let's just think of that negative 64 as a negative 1 times whatever else is there. So in this case, negative 1 times 64. And if you see that, then we could say and break it up, well, that's still just negative 1 times the square root of 64. Break them up separately. We know 64 is 8, and so we're still getting x equals plus or minus 8, and then we'd have times that square root of negative 1. And yes, we'd still have the plus minus. So that square root of negative 1 kept getting in the way. So they kept putting it and putting it aside, and they finally said, we're going to call it I for imaginary. And so our answer on this one ended up being plus or minus 8i. So with that was born the idea of imaginary numbers. And it goes something like this. If you have an imaginary number, you know that I will be equal to the square root of negative 1. And that means then if I take I and square it like we normally do, multiply it by itself, I squared would be equal to negative 1. And if you know these two pieces of information, you can work in the imaginary number system very easily. So we're asking, please memorize that I is always equal to the square root of negative 1, and that I squared equals negative 1. Now, a good definition now that we know we have something called an imaginary number is a non-real number that can be written in the form of bi, meaning you're going to have an I in your answer somewhere. And you always simplify it. You never leave the negative square root as part of your work. So knowing that, let's move ahead and take a look at these different combinations. So imaginary numbers. The names are all the same. So I have 4 different combinations here, and I could say the solution to x squared equals negative 7. So in other words, the answer to that statement is the same as the square roots of negative 7, which is the same as writing it in mathematical form, square root of negative 7 and negative square root of negative 7. And last but not least, what we're going to aim for in this section now is taking out that negative 1 square root and inserting an I. And when we have that, we would have had I root 7 and negative I root 7. So all four of these things, whether it's word form, symbols, or symbols with our symbol for the negative square root of 1, so our I, they're all equivalent. So now we're going to ask you to start simplifying with these numbers. You can say, well, wait a minute, I didn't even learn what they are. You can do this because you know how to work with real numbers. So the imaginary number, you can see, we got an I, we got a negative root, we got two negative roots. So all of these would be imaginary numbers. But let's go and do our math. So in this first one, if I said 8i squared, most of you would be looking at, well, that's just 8i times 8i, if you want to think of it, multiply it by itself. And you can do that. Numbers times numbers, variables times variables, we would get 64i squared. But you just learned on the last slide that I squared is better known as negative 1. So we could write that and finish the multiplication. 64 times negative 1 is negative 64. So notice, we started in the imaginary system, because that's what that was, and we got down, and this is a real number answer. So by multiplying, we were able to get into the real numbers. Interesting. Let's try the next one. Again, most of you would look at that and say, well, wait a minute. On that last page she was describing, just think of that square root of negative 49 as a negative 1 times positive 49. Then you can break them up separately if you'd like. And you'd have the square root of 49 and the square root of negative 1. You'd still have your negative 3 out front. And let's multiply. We know the square root of 49 is 7. So we'd suddenly get this. Then you can say, well, wait a minute, we got two numbers there. Negative 3 times 7 is negative 21. But the square root of negative 1 we just learned was the same as I. So our final answer in this case is negative 21i. And if you look at that again, we were in the imaginary number system, and this would still be considered an imaginary number. It has an I in it. It belongs to the imaginary number system. All right, our last example, same way. Let's go ahead. Let's try to make that big jump a little quicker this time. You know the square root of 9 is 3. So with that square root of negative 1 in there, most people would say, well, that's 3i. Times by, do the same thing with the square root of negative 121. We would get 11i. Now go right back to like we did on the first example. What is 3i times 11i? Most people would say 33i squared. 33i squared, but I squared is better known as negative 1, so negative 33. So there's an example of how we're going to work with powers, roots, square roots in the imaginary number system using our idea of I equals the square root of negative 1. So on this one it says, and let's start with just the first one. Give us a little room here. Show that I square root of 7 is a square root of negative 7. So if this is a square root, that means we should be able to take that and square it and to get back to what they asked for. So we're trying to find out, is it really equal to a negative 7? So let's do our math, which means I root 7 squared is nothing than it multiplied by itself. Okay. I times I is I squared. Square root of 7 times square root of 7 is square root of 49. But square root of 49 is better known as 7. And from there, I squared equals negative 1. So negative 1 times 7 is negative 7. So you have just shown that our left-hand side does, in fact, equal that number of negative 7. I root 7 is the square root. So we squared it, we multiplied it out, and it did come out to be negative 7. Second choice. If we look at this, it says solve 2x squared plus 100 equals 0. It's a quadratic equation. Yes, you could use a quadratic formula, but notice it has a term missing. That middle term, the bx term, is missing. So this is actually easier, similar to what we did in the beginning of the chapter, Meaning, let's solve, let's get x by itself. Let's not use anything fancy. Let's just move that 100 to the other side. 0 take 100 leaves a negative 100. We still don't have x by itself, so our next step would be to undo that with a divide by 2. So x squared now equals a negative 50. And as soon as we look at that, I'm going to move it up here a little, we should be good to go. If we have an x squared equals negative 50, most of you know to undo a square means take a square root. And so if I take a square root of both sides, I would get x equals plus or minus, and we're looking at that negative square root. We've now learned that a negative square root is always factored by taking negative 1 times that number. And negative 1 times that number, the square root of negative 1, I should say, is that I value. So we're going to end up with plus or minus I, and we still have the square root of 50. Now, what you have to remember is you have to be able to simplify square roots. So start thinking about perfect square numbers. What is the biggest perfect square number that goes into 50? And in this case, the biggest square root would be the 25. So I'm going to think of it as 25 times 2. Big square root there. And now the square root of 25, we should know, comes out as 5. So we're going to get plus or minus 5i root 2. Final answer, part whole number, part imaginary, and we still have that radical because it was not a perfect square number. So in essence, we've got a variety of answers that we're getting, but that is the simplest form of that equation. And that's exactly what you would have gotten if you would have used the quadratic formula. This just is a step or two quicker. All right, so we now have introduced you to imaginary numbers, and we're going to expand that set as we go. But for today, I think you're good to go. We need to be able to do some multiplying, adding, subtracting with our numbers. But you know how to add and subtract, so you should be on your way. So let's see again. If you have any questions, bring those to class, and we'll work together on those.